AI is absolutely everywhere, right? I mean, you've got ChatGPT writing your emails, Gemini creating unbelievable images. It feels like a total tech explosion. But what if I told you that this entire revolution, all of it, is built on one single brilliant idea that's not even a decade old? Yeah, this didn't just happen out of nowhere. It was kind of a slow burn for years, and then, boom, it went completely exponential. So what was that one big idea? What was the spark that lit this incredible fire? Well, that's exactly what we're going to unpack right now. To really get what changed, we first have to go back in time. We need to understand the world before the revolution. Let's call it the age of one task, one model. So before about 2018, building an AI was a lot like hiring a very, very specialized craftsman. Each deep learning model was painstakingly designed and trained for one single job, and one job only. You wanted an AI to spot cats in photos? Great, you built a cat model. Needed one for cars? Well, you had to start all over again and build a completely separate car model from scratch. Now, there were some upsides. These little specialized models were pretty small and efficient, but the downsides, they were massive. Each model was basically stuck in its own little world. The cat model learned absolutely nothing from the car model. It had to, as one expert put it, start from scratch, literally, to gain its skill. You can imagine this was just incredibly inefficient and super expensive. So, you see the problem, right? This whole starting from scratch thing was a huge roadblock. The entire AI community knew they needed a way for these models to somehow share their knowledge. And that need led to the first real leap forward. And that leap was called transfer learning. And honestly, the name kind of says it all. Instead of building every single model from zero, you could now take a big model that was already trained on tons of general information and then transfer its knowledge to a new but related job. This was a total game changer at the time. So how'd it work? Well, it was a pretty smart process. You'd start with a big pre-trained model. Then, you'd tack on a few new smaller layers for whatever your specific task was, say identifying different species of birds. And then, here's the key, you only had to train those new layers. It was way, way better, but there was still a catch. You still had to tweak and fine-tune a new version of that model for every single task. A big step, for sure, but it wasn't the final answer. Okay, this is where this story goes from interesting to truly dramatic. Transfer learning was a great improvement. But what came next? It was the kind of revolutionary idea that changes a field forever. This was the aha moment that flipped everything we thought we knew about AI on its head. The biggest challenge that even transfer learning couldn't really crack was context. See, older models read information sequentially, one word at a time, in order. And for understanding language, that's a huge problem, because the meaning of one word can totally depend on another word that's way earlier in the sentence. So the big question was, how do you solve that? How do you get an AI to see the whole picture at once? This timeline really puts it into focus. 2012 was a big deal. AlexNet showed that deep learning could actually work on a massive scale. But the real earthquake happened in 2017. Researchers at Google published a paper with a kind of quirky title, "Attention is All You Need," and it introduced a totally new design, a new architecture called the transformer. And this is where the AI revolution we know today really kicks off. And this is just a brilliant way to understand the difference. The old sequential way was like reading a book one page at a time. By the time you get to page 10, you've probably forgotten the details from page 1. But the transformer, it processes information in parallel. It's like being able to see all 10 pages of the book spread out in front of you at the exact same time, instantly understanding how a word on page 7 connects to an idea on page 2. So what's the secret sauce? What's the magic that lets the transformers see that whole book at once? It's a mechanism called self-attention. Basically, it's a way for the model to look at every single word in a sentence at the same time and instantly figure out which other words are the most important for understanding its meaning. This was the elegant solution to that massive context problem. So, with the incredible power of the transformer architecture finally unlocked, the stage was set for a completely new type of AI. It was time for the hero of our story to make its entrance, the foundation model. And to really get just how massive this shift was, we have to talk about scale. Back in that old era of specialized models, what we all considered a large model was measured by its number of parameters. And that number was less than 100 million. Now, just think of parameters as the little dials and knobs inside the AI's brain that it uses to learn and make decisions. For years, 100 million was pretty much the top of the line. Just keep that number in your head. Because today, thanks to the transformer, a modern foundation model isn't just a little bigger, it's not even on the same planet. Today, it can have over 1 times trillion parameters. Let that sink in. That's not a small jump. That is a leap of more than 10,000 times in scale. It is the difference between a small village and a sprawling megacity. It's a whole new world. And this chart just lays it all out, clear as day. Look at the progression from specialized to transfer to foundation models. The model size, the insane amount of data they're trained on, and most importantly, their ability to generalize and tackle new problems. It's just exponential growth across the board. We went from models that couldn't generalize at all to models that are incredibly good at it. So, what is a foundation model? Well, it's a single, absolutely gigantic model built using that transformer architecture and trained on a truly astronomical amount of data. And the name is perfect because it acts just like a building's foundation. You invest all this time and money to build it once, and then you can quickly and easily adapt it to build lots of different houses or applications right on top. This incredible scale unlocks abilities that honestly feel a little bit like magic. There's few-shot learning, where you can teach the model a brand new skill with just a couple of examples. Even crazier is zero-shot learning, where it can do things it was never specifically trained to do. These are called emergent abilities, these wild, unexpected skills, like the ability to write computer code or poetry that just sort of appear as the models get bigger and bigger. And that brings us right up to today and gives us a peek at what's just around the corner. Because this new foundation, it isn't just for text anymore. It's evolving again. But before we look ahead, let's make this super concrete. This isn't just some theory. You use these models constantly. When you're chatting with ChatGPT, you're not talking directly to the raw foundation. ChatGPT is the product. It's the house that OpenAI built on top of its GPT foundation model. That's a really important distinction. The foundation is the engine, and the product is the car you drive. So the next big frontier is making these foundations even more powerful by making them multimodal. What does that mean? It means a single foundation model, like Google's Gemini, can understand not just text, but also images and audio and video all at the same time. It's the next step towards creating a truly general-purpose AI that can understand the world more like we do. So when you really look back, this AI revolution we're living through wasn't just about getting more data or faster computers. It was about one brilliant idea, the transformer, that gave us a completely new blueprint for building intelligence. The last decade was all about laying this incredible, powerful foundation. So the big question for the next decade is, what are we going to build on it?